Hello everyone. I am Ammehani studying CSE Artificial Intelligence in Sri Venkateshwara College of Engineering. I welcome all of you for today's my channel. I belong to Department of CSE Artificial Intelligence and my USN is 1VE22CA058. The subject to discuss today here is Mathematics for CSE stream. Subject code BCS301. Let's move forward. Basic concepts of probability theory is the topic for today. Introduction to probability theory. Probability theory is the branch of mathematics that studies the likelihood of events occurring. It provides a framework for understanding uncertainty and making informed decisions. Probability theory is widely used in various fields, including statistics, economics, and engineering. Let's move forward. Sample space and events. What is sample space and events in probability? It's nothing but a sample space is the set of all possible outcomes of an experiment. An event is a subset of the sample space representing a particular outcome or a combination of outcomes. As we can look into the picture, sample space is denoted by S. As I told you before, it's nothing but a set of all possible outcomes of an experiment. For example, if a single die rolling experiment, the sample space will be S is equals to 1, 2, 3, 4, 5, 6. Experiment is occurring when you are tossing a coin. So sample space S is heads, tail. That's nothing but heads, tails. Events can be classified as simple or compound depending on either they consist of a single outcome or multiple outcomes. Probability of an event. The probability of an event is a number between 0 and 1, exclusively that represents the likelihood of that event occurring. The probability of an event is denoted as P of A. For example, P of E is equals to total number of outcomes in event E dividing by total number of outcomes in sample space S. That's nothing but P of E equals N of E dividing by N of S. The sum of all probabilities of all possible outcomes in a sample space is always equal to 1. Probability rules. The addition rule states that the probability of union of two events A and B is given by P of A union B is equals to P of A plus P of B minus P of A intersection B. The complement rule states that the probability of the complement of an event A is given by P of A dash is equals to 1 minus P of A. The multiplication rule states that the probability of the intersection of two dependent events A and B is given by P of A intersection B equals P of A. Conditional probability. Conditional probability is the probability of an event A occurring given that another event B has already occurred. It is denoted as P of A dividing by B and is calculated using the formula P of A dividing by B is equal to P of A intersection B dividing by P of B, where P of B is not equal to 0. Conditional probability help us update our beliefs and make predictions based on new informations. The independence of events. So basically, what is independence of events? For example, two events A and B are independent events. If the occurrence or non-occurrence of one event does not affect the probability of the another event, so mathematically, two events A and B are independent if P of A intersection B is equals to P of A into P of B. Now, P of A dash intersection B is equals to P of not A and B. P of B minus P of A intersection B, okay, P of B minus P of A intersection B Then the next step is nothing but, as we have proven, like two events A and B are independent if and only if P of A intersection B is equal to P of A into P of B, as we have mentioned in the picture over there. So what happens? P of B and P of A into P of B changes to 1. 1 minus P of A. P of B into P of A dash. Okay, so it's proven, since P of A intersection B is equals to P of A dash dot in the sense into P of A dash into P of B. So here what happens here is P, hence A dash and B are independent. As I have mentioned in the previous thing only, that two events A or B are independent if the occurrence or non-occurrence of one event does not affect the probability of the other event. As also we looked into the picture. As an example, expected value. So what is expected value? Expected value or expectation or the meaning of the random variable x of s on the sample space is equal to e of x summation of x belongs to s, p of s, x of s. So the expected value, also known as the mean or average, is the measure of the central tendency of a random variable. It is calculated by multiplying EZ or each possible outcome by its probability and summing these products. The expected value provides a way to quantify the long-term average of a random phenomenon. Variance and standard deviation. So what is variance? Variance is the measure of the spread or dispersion of a random variable. It is calculated by taking the average of square differences between each possible outcome and the expected value. Standard deviation. What is standard deviation? It's nothing but it is the square root of the variance and provides a measure of the variability in the data. Law of large numbers. So basically, what does this law state us? It states that as the number of trials or observations increases, the observed relative frequency of an event converges to its true probability. In other words, with more data, the empirical probability approaches the theoretical probability. The law of large number is a fundamental principle of probability theorems and forms a basis for statistical inference. So, by concluding the session, let me tell you, first of all, let me give an introduction of types of probability distributions, characteristics, examples, and graph. So, in types, basically, we have four types. First is discrete distribution. Probability distribution is also a discrete distribution in that we are having subtypes. That's nothing but Bernoulli's distribution, binomial distribution, uniform distribution, Poisson's distribution. Okay? And the next one is continuous distribution. So in continuous distribution, we have the subtypes, that is normal distribution, chi-squared distribution, exponential distribution, logistic distribution, student's t distribution. So, by telling this, let me conclude the session. Probability theory is a powerful tool for modeling and analyzing uncertain events. It allows us to quantify and understand the likelihood of different outcomes. By applying the basic concepts of probability theory, we can make more informed decisions and draw accurate conclusions. So, by concluding the session, thank you. I would like to inform, please like, share and subscribe my YouTube channel. Thank you.